Hello guys, I'm Paul McWhorter, and today we are on lesson number 4 on using the Arduino microcontroller with Python to create a little virtual world. And we will be expanding our virtual world today, and I will show you what we're going to do. If you look down here, what you can see is we have the real world. We have an ultrasonic sensor, we have a color sensor, and we have a target. And what we match with this circuit is we match both the color and the distance to the target. So you see our target is green, and as I move it in and out in the virtual world, which is over here, everything sort of tracks. Okay, so let's try going to a different color. Let's say I go to orange. I bring the orange card in, and the virtual world turns orange. And then as I move the orange card in and out, it tracks in the virtual world, just like that. Okay, let's try a green card. I come in with the green card, and the virtual target turns green. And let's come out here and look. You see that little red dot? As I come through that little red dot, I can slice it right down the middle, and what happens in the virtual world is tracking what's happening in the real world. I can come on through it like that, or I can come back and it disappears. Watch it reappear from behind. And I just think this is really cool that I've got a little virtual world over here, and it tracks what happens in the real world. And I can try all types of different colors of cards. Let's see, let's get that one. You see we've got purple, we've got blue, I've got pink, I've got lime green. Becomes a nice lime green. Let's look at that now. Let's try yellow. Yellow's kind of a hard one. Let's see if we can get that yellow there. Yellow's wanting to go up. There it goes. We got the yellow. Yellow sometimes wants to go a little bit orange on us. Come back to the green, and it's got green. Go to the orange. Now I can just start picking up stuff here and put it in there, and it does very well to match both the color and the position. And so I think this is just a really fun project, and I'm going to take you through it step by step. Now what we're going to have to do, this is a little bit more complicated program, so we're going to have to break it into two different lessons. And in today's lesson, what we're going to do is we're going to go through the code to get the Arduino side of things working, where we're making the measurements. And really what you got to do is you got to measure a distance to a target, and then you got to measure a color. And then you got to send that data over your serial port, and then you got to have a Python program that gets that, creates the virtual world, and then dynamically updates the virtual world. So what we will be doing today is we will be working on the Arduino side of things, and then in tomorrow's lesson, we'll be building the Python program. So we're going to learn a lot of neat stuff here in the next 2 days. Let me show you where we are. We're at toptechboy.com. And if you want some material here to support some of the supporting description and stuff, you can always come here. Toptechboy.com. We are in the sequence, of tutorials of using Python with Arduino. You can click there, and then you can come down and see that we are on lesson number 4. And you can click there, and then you can see this is a picture of my little circuit that I built. Yours will look something like that. I've got some sources if you need to get the sensor, if you need to get the color, the ultrasonic sensor, the color sensor, the Arduino. The other thing is that this color sensor is too big to plug into the PC board, and so you have to hook jumper wires directly to it. So you will need some of these male-female jumper wires if you don't already have them. If you're in my classroom, all you've got to do is just go back to the supply cabinet, and it is full of these guys. Okay, we got to get this circuit hooked up. The ultrasonic sensor you can hook up according to this diagram. It's pretty easy. VCC goes to 5 volts, ground goes to ground, the trigger pin goes to pin 13, and the echo pin goes to pin 11. I show these things connecting in front of the sensor, but you don't want to connect in front, you want to connect behind. You don't want these wires to get in the field of view of this sensor and impact the measurements. You can see the way that I hooked it up, I've got the wires in that order, but they're hooked up from behind. Okay. Now you're also going to need to connect the color sensor up. I couldn't really show the color sensor on this diagram, so I just show you that if you look at the color sensor, there are 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7 of the 8 pins you have to hook up. I think that there's an output enable or something like that that you don't really need to hook up. But your pin that's labeled S0 needs to, on the Arduino, go to ground. Your S1 needs to go to 5 volts. Your S2 needs to go to pin 7. Your S3 needs to go to pin 8. Your out pin needs to go to pin 4 on the Arduino, VCC to 5, and ground to ground. Always make sure all your grounds are hooked together, that the ground of the ultrasonic sensor and the Arduino ground and the ground on your color sensor all need to be hooked together. You always need to have a common ground. Okay. So with that hooked up, I think we can start developing our code. And what we're going to have to do is we're going to be combining what we learned in several of the other lessons. And so I don't think that this is going to be a whole lot of really new stuff. But it is a lot of stuff, so let's go through it. Let's go through it step by step, and it's just good practice so that we kind of get good at programming. So what do we do at the start of our programs? Well, we like to kind of declare our variables, and so we've got some pins that we hooked up. Let's do the color sensor first. Remember, on the color sensor we had the pin S2. Okay, and we said we needed to connect that to 7. Well, you got to let Arduino know what you're doing. You connected it on your board, but Arduino needs to be part of the project, needs to be part of the team. So we need to let the Arduino know that the color sensor pin is pin S2 is connected to Arduino pin 7. Okay. Then also we had an S3 pin on the color sensor, and it goes to pin 8. All right, so color sensor pin S3 goes to Arduino pin 8. And I made some little strange mistake there. Okay, that looks good. Let's always put our comments in, so when other people are looking at our code or we come back later to look at our code, we know what we're doing. Now what S2 and S3 do is you select those pins to say which color you want to measure, and so when we start getting into making our measurement, like we'll send S2 high and S3 high to measure one color, or S2 high and S3 low to measure a different color. So these basically are the pins that we're going to output to, telling it what color we want to measure. All right, then there's a pin that we measure, and on the sensor it's called out pin, and we're going to connect that to Arduino pin 4. So let's set that up like that. So we have color sensor out pin connected to Arduino pin 4. Right, is that right now? Okay, now I'm going to skip a line just to kind of format things. Now we need to hook up the ultrasonic sensor. So on the ultrasonic sensor we had a trig pin, and that we said to go to pin 13 on the Arduino. So this is ultrasonic sensor trig pin to Arduino pin 13. Okay, then we also on the ultrasonic sensor had an echo pin, and that was going to go to pin 11 on the Arduino. So ultrasonic sensor echo pin to Arduino pin 11. Okay. Now we got to think about what we're measuring, and we got to set up our variables. Remember, we got to declare our variables up here, and let's think what we're doing. Well, we're going to measure color, and so we're going to measure 3 colors. R, the G, and the B, red, green, and blue. So we need to set up variables for that. So I'm going to call it R color I have trouble strength. Okay, our color strength. And so this is the measured strength of red color. Okay, then we're going to have G color strength. This is going to be measured strength. I misspelled this up here, didn't I? Strength. I have trouble spelling these words. Strength. THs like height and length. You know, TH versus HT. That kills me. Strength of green color. Okay. Then we're going to have blue. So B color strength is the measured strength. Okay, I think I got it there. I am severely dyslexic, so it is hard for me to get these things in the right order. So you have to be patient with me. Okay, measured blue color. Okay, so now those are going to be our colors. What else do we need? Well, when we make those things, the thing we actually measure is we measure a pulse width. And remember, on this ultrasonic sensor, that pulse width can be really big. It can be up to 102,400, so we can't make it a normal int. We have to make it an unsigned int, which basically we're telling it we're only using positive numbers, and because we're only using positive numbers, it'll let us go out to much, much bigger numbers, because a normal int would not hold a number of 102,000. So we need to make this an unsigned int, and we will make it pulse width, and that will be actually for measuring color strength pulse width. Remember, the way we measure these color strengths, we come up and we set these pins to what color we want to measure, and then we do a pulse in measurement, and we read that into the variable pulse width. So that's where we're going with this, in case you were wondering. I hope you were yelling at me to put my semicolon. You're probably sitting there watching my spelling and watching my typos, just sitting and yelling at me, but you correct it when you find me making a mistake. And I'll correct it later when I run the program. Okay, we're going to need to measure distance, okay? That's on the ultrasonic sensor. And to do that, we're going to have to measure ping time. Remember, we send out a ping and see how long it takes to come back. Okay, so this is the time for ping to travel to target and back. Okay, so what we're doing down here, let me set up a target. This ultrasonic sensor is sending out a ping, and it goes out to the target, it bounces back. So we got to set up this, this variable for measuring that ping time, because that's how we are going to, in the end, measure the distance. So we do that a float because we're going to be doing some calculations, and we probably will be better served by a floating point number there. We're also going to do a float for target distance. Okay. So this is going to be our measured distance to target, and so that's going to be the distance between the sensor and the target. Now understand, the ping goes to the target and comes back, and so the actual distance to the target is half the distance that the ping travels. So when we calculate distance from ping time, we need, that's the distance the ping travels. We're going to have to divide by 2 to make sure that we get the target, the distance to the target. But you should know that because we talked about that in an earlier lesson. Okay, we're also going to need, if we're going to measure distance as rate times time, and we measure the time and we want to calculate the distance, we need to know the rate. Well, how fast is that ping traveling? That ping is traveling at the speed of sound, and so we need speed of sound, and that we know is 776.5 miles per hour. So this is the speed of sound in miles per hour. Now we're going to have to remember that we're entering the speed of sound in miles per hour, and so when we just measure our distance, the distance we measure is going to be given in miles, and so we're going to have to convert that to inches. So we got to keep track of our units and be real good with our dimensional analysis. So I think those are the variables we need. Let me get rid of some of this white space here. And let me get rid of this comment. So the void setup is where we do things that we need to do one time. And so always we need to turn our serial port on. So serial.begin. Okay, and I want to speed this up. I'm going to go 115 200 on this, and we just got to remember now when we call up the serial monitor, we need to use this. And also, this serial port we're going to be using to send the data to Arduino. Send the data to Python. So when we go over there on Python and set up our object to read this data coming in, we need to remember that we used a baud rate of 115,200. Okay, so this is turn on serial port to baud rate of 115,200. Okay, so we got that on. Also, we need to do our pin modes. Okay, so our pin mode, what do we have? S2. Okay, S2 we are going to write to, so it is an output. Remember, output all caps. Okay, that looks good. Tell Arduino S2 is an output. Okay, pin mode. What else did we do? We had S3 up here. So S3 is set to an output because we write to it as well. And tell Arduino S3 is S3 is an output. Okay, and remember what S2 and S3 are doing. That is sort of that we'll use to set high or low to tell the Arduino what color we want to, what color we're measuring, or to tell the color sensor what color we want to measure. Okay, now we also have our out pin. We're going to read to that. The sensor is outputting data to the output, to the out pin, and so the Arduino is reading from that. And since the Arduino is reading from that, our out pin will be a what? It'll be an input as far as the Arduino is concerned. Okay, so since the color sensor out pin is Arduino input, if that makes sense. So if the color sensor is outputting something to Arduino, that's an input. All right, so we've got our pin mode set up there for that sensor. We also have the other sensor, which is our ultrasonic sensor, and there we had trig pin. Okay, that's something that we send the trigger to send that pulse out, and so that's an output because we're going to write to it. Ultrasonic sensor trig pin is Arduino output. Okay, now we're going to have a pin mode, and we also have, what do we have up here? We have the echo pin. Okay, and we're going to read a pulse width coming off of that echo pin, and so to the Arduino that's going to be an input. So this is the ultrasonic sensor echo pin is Arduino input. Okay, it'll be an input to the Arduino. All right, so I think we got most of our pin modes set up, and I think that's probably all we need to do in our setup. We turned on our serial port, and we did our pin modes. Okay, now we got to come down here, and we got to make some measurements. All right, and so what are we going to do? What do we want this thing to do? Well, if we come back and sort of look at what's going on here in the virtual world, we are measuring what? We're measuring three colors, red, green, blue. So when we put something in front of this color sensor, we want to measure the relative strength of the red component of the color, the green component of the color, and the blue component of the color. So we need to go out and we need to make those measurements, the red color, the green color, and the blue color. So let's start by reading red component of color. Okay, so how do we do that? We do a digital write, and we want to write to S2 and S3. And S2 and S3 should both be low. So to measure red on this sensor, okay, both S2 and S3 should be set low. Okay, so we're going to do a digital write. What pin? S2. What do we want it? Low, because we want to measure red. Okay, I don't think I need to comment that. Digital write, and then S3, and we're going to go low. Okay, so that will make us measure red, or we're getting ready to measure red. Now, to actually make the measurement, what do? Well, when we set S2 low and S3 low, this sensor starts looking for the red component. And the way it communicates that to us is to the output pin, it sends a pulse. And the length of that pulse is sort of proportionally information about what the red strength of the color is. Now it's kind of goofy, but let's go ahead and make the measurement. So remember how we set up that variable pulse width? Okay. And then we're going to measure the pulse, the length of the pulse in. Where are we going to measure it? Well, on the color sensor up here, we called it out pin. That was the pin coming off the color sensor, pin 4, that we were, or pin 4 on the Arduino, the out pin on the color sensor that we're going to make our measurement at. So we're going to say out pin, and then this is a low pulse. So the way this thing does is it stays high and it goes low to send us the data, so it's the length of that low pulse that we are looking for. Okay, so measure pulse width of low pulse at out pin on color sensor. All right, so we make that measurement. Now that pulse width is a goofy number, and we got to know how to deal with it. It's going to send us a pulse width that's between 0 and 102,400 microseconds. Okay, and the goofy thing is, the longer the pulse width, the bigger the number, the weaker the color is. So we've got to do some manipulation. First thing is, if I have the number between 102,400, between 0 and 102,400, I want to convert that to a number between 0 and 255, because remember, in the colors that we deal with colors between strength of between 0 and 255. Well, how can I do that? Well, after playing around with it, what I saw was that and let's go ahead and make this our color strength. Am I spelling that right? Okay. So first thing we want to do is we want to take the pulse width and we want to divide by 400. Okay. So if I take the pulse width, the maximum the pulse width could be is 102,400. If I divide that by 400, that brings it down to 255. So that means I'm going to be scaling these numbers I'm reading that are going to be between 0 and 102,400. I'm going to scale those to numbers between 0 and 256. Almost there, but we want 255. Okay, so if I take 102,400 divide by 400, I could get a maximum value of 256. Well, I don't want it to be more than 255, so I will subtract 1. Okay, so I'm going to convert measured pulse width to a number between 0 and 255. I hope this makes sense. If it doesn't, go back and look at our earlier video where we focus on this color sensor. All right. Now, the other problem is that, remember, the weaker the color, the longer the pulse width, and the stronger the color, the shorter the pulse width. We got to reverse that, because the way the world thinks is 255 is a strong color, 0 is a weak color. So what we need to do is we need to reverse that by saying our color strength. I did not create this sensor. I'm just telling you how it works. So we reverse it by saying 255 minus our color strength. Okay. Reverse, so large, so strong color is a large number. Okay, so it's just if it's given us that 1 is a really, really big number, we want 255 to be the big number. So we're just basically reversing it. And then it'll be working like the rest of the world thinks things should work. Okay, now I am going to just live very dangerously here, and I'm going to cut and paste this, because the next thing we want to do is we want to do the next color, which is going to be green. And so I'm going to come in, okay, and now let's make this green. So let's read green component of the number of the color. And so for the green, to measure green, the way we know, because I have studied this sensor, is S2 and S2 should be, let's see, S2 and S3 should be high. Okay, so if we're going to measure green, we want to set S2 and S3 high. When we measured red, we wanted S2 and S3 set low. So here we come in and we're going to make this high. We're going to make this high. Okay, the pulse width is still that same measurement. It's just we've set these up differently to measure green. Okay, and then here, now this would be G for G color strength and G for G color strength. And so I think now I have measured green already. We are going to just be going really fast. So let me copy this, let me paste again, and we need to do what this time? Let's measure blue. Okay, so let's measure the blue component of the color. And so on the blue component of the color, S2 should be low, and S3 should be high. So S2 is going to be low, and S3 is going to be high. Then we're going to do the pulse width measurement. Then all of a sudden this becomes the B color strength, and this becomes the B color strength. This becomes B color strength, and I'm messed up here. This is G color strength is 255 minus G color strength. I'm glad I remembered to check that. That would have been one of those really strange ones where the program works some of the time and for other colors it doesn't. And so R color, G color, G color, G color, B color, B color, B color. I think that looks good. I think that's going to work. All right. Now here's the problem with the color sensor. When it gives you a reading, the red, the green, and the blue are all really close together. And if we try to do something with it, they're so close together, it doesn't help us very much. So we got to amplify the differences, okay? And there's probably really formal ways that you could calibrate this thing, but I just like to try to think, is there something simple that works for most things? And so I want to exaggerate the colors and exaggerate the differences between the colors. So when I put something like this here, I don't want to see R250, G250, and B252, you know, where the three numbers are almost the same. The point is that blue is biggest there. All right, so I want to exaggerate that. So what I'm going to do is, this is the algorithm that I'm going to use. I'm going to look at the red component of the color, the green component of the color, and the blue component of the color. Whichever color of those three colors is the biggest, okay, I'm going to set that to 255. So whatever the strongest color, so if this is blue, is the largest, I'm going to go ahead, I'm going to set blue to 255. Okay, if green is the largest, I'm going to set green to 255. If red is the largest, I'm going to set red to 255. So it's just like the card is mainly red, is what I'm saying. Similarly, of the red, green, and blue components of the color, whichever is smallest, I'm going to set it to 0. So it's like the winners are going to win and the losers are going to lose. So if it's mainly red, I'm going to set it to 255. If blue is the smallest, I'm going to set it to 0. And then the color in the middle, because I do want to get all these colors. You see, I want all these in-between colors, and so I just can't have red, green, blue. Those are your only 3 colors. So this is what seems to work. The color in the middle, I divide by 2. And so like if red is the biggest, I set it to 255. Blue is the smallest, I set it to 0. Let's say green was at 250. I take green and I make green is equal to green divided by 2. So I tone down the middle one by a factor of 2. Maximum, the largest color goes to 255. The smallest component of the color goes to 0. And the middle color goes to the middle color divided by 2. It works surprisingly well, as crazy as it sounds. I hope someone will come up with a better way of doing it and tell me how to do it better. But until then, this thing, I mean, come on, this thing, look at this. I put orange there. Let's see. I put orange. That's a pretty good orange, right? I put green. That's a pretty good green. I put lime green. That's a pretty good lime green. I put pink. I'm getting a pretty good pink. So purple's a little tricky sometimes, but let's try purple. Okay. Yeah. Actually, that purple is working amazingly well. That purple is working amazingly well. So this, as goofy as it sounds, and that one is the one that it has a little bit of trouble with. So let's quickly put one that works better up here. There. Okay. So this little algorithm that I just described to you, it works amazingly well. So I'm going to have to kind of go through the different possibilities of which is bigger. Okay. So the first would be, let's say that, what do? We got to kind of do an if statement. So let's say if R color strength is greater than, I've got to spell this one time right. R color strength. Okay. I'm just going to copy and paste this now. Okay. So if R color strength is greater than green color strength and green color strength is greater than blue color strength. Okay, so what is this? This is the case where red is strongest and blue is weakest. Okay, and of course with that, and I had better close this up here like that, and I'd better put a clause in here, right? I'm acting like this is Python or something. Okay, so if R color strength is greater than green color strength and green color strength is greater than blue color strength, then what do? Okay, and let's go ahead and close our clause there so we don't get in trouble. All right, so what do? This is saying R is the biggest, green is in the middle, and blue is the smallest. Well, then what we do is R, and I'm going to paste it, R color strength, I'm going to set equal to 255. Why? Because it's the biggest one. And then G color strength, what do? It's in the middle. What do we do with the ones in the middle? We set it equal to green color strength, divided by 2. Okay? And then poor blue, he was the loser. He was the smallest. We're going to kill him, make him 0. Okay. So the biggest one went to 255, the middle one we just divided by 2, and the middle one we kill. All right? Now, that is that case. So we got to do this 6 times. All right? So that was red, green, blue. So this time let's go red still the biggest, and let's go blue in the middle, and green the smallest. And so this is where red is the strongest and green is the weakest. Okay, so now let's let's see what we want to do there. Okay, red is still the strongest. This time blue is in the middle. So we make this a B. We make this a B. And this time green is the weakest. So green is what we kill. All right. So now we've done the case where red is the biggest. Now let's do the case where green is the biggest. Okay. So we come up here and green is the biggest. Red is in the middle. Red is in the middle. And blue we're going to kill. So this is green, red, blue. And this is the case where green is the biggest and blue is going to get killed. So here green is the biggest, so we need to set green to 255, and then red is in the middle, and so red we're going to divide by 2, and blue is the smallest, and so we're going to kill blue. Okay, and understand this and means that this has to be true and this has to be true. So when green is greater than red and red is greater than blue, then that means green, red, blue is the order. And I think that we have done this right. Okay, now I'm going to copy this one because the next one will be similar to it. Okay, and now this one is case 4, and in this one still we're going to keep green the biggest, but in this case we're going to put blue in the middle. And we're going to make red the small one. Okay, this is still where green is the strongest, and this time red is the weakest. So here we go. Green is still 255. This time blue is in the middle, so blue is blue divided by 2. And then what is the small one? Red. We're going to kill red. Okay, so now we've got the case of we've got the case of red the biggest, all the possibilities, green the biggest, all the possibilities, and so now we need to go for what happens if blue is the biggest. So I'm going to copy this one. Okay. All right, so now this time, what do we want? Okay, I want blue the biggest. So this would be blue is going to be bigger than red, and red is going to be bigger than green. So case where blue is the biggest and green is the weakest. And so blue is the biggest, so blue gets set to 255. What is in the middle? Red gets cut by 2, and poor green gets killed. Okay. I hope I did not get my end clause on that one, I don't think. So make sure, let's check. So I've got a begin clause, end clause. This ends the whole void loop. So I didn't copy in there somewhere. That is that one, that is that one, that is that one, that is that one. Okay, that is that one. So we're getting them all in here. Okay, so this is blue color. So now let's copy this again. Okay, and now let's put it in here. Okay, so this one is going to be for the case blue is still the biggest, but this time green is in the middle. So I turn those to green, and red is the smallest. So this is the case where blue is the biggest and red is the weakest. So blue's the biggest, that goes there, and then green is in the middle, so green gets divided by 2. Okay, and then blue gets killed. All right, so we've done all 6 possibilities. 1, 2, 3, 4, 5, 6. We've done all the possibilities. So now our red and green and blue numbers should represent something that we could sort of feed to a program and turn things actually colors that sort of would make sense. So that is going to work pretty good, I think. So we go through all of those things. Now what do we need to do? We've measured our colors. What's the other thing that we need to do here? If we go back to our program, we need to be able to measure distance. Okay, so we've got to be able to measure this distance. All right, let's measure this distance from the ultrasonic sensor. Okay, so we have done this in an earlier lesson, so this should be pretty easy. I'm not going to tell you, I'm not going to spend a lot of time on it, but remember what we got to do is we got to digital write, and we got to go to that trig pin, which we set up above on the ultrasonic sensor, and we got to set it low. Okay. Then what we got to do is we got to delay to let the delay, and I'm going to delay in microseconds. So we're working in microseconds here. About 2,000 microseconds, that's 2 milliseconds, that's 2/1000th of a second. That's just when we bring that trigger pin low, let it settle. Okay, now we got a digital write, and then we're going to take the trig pin, and we're going to set it high. We got to create a pulse, low, high, low. Okay, so now we take it high, now digital write, and then we're going to go trig pin. Oh no, we got to delay again. Okay, so I'm going to delay microseconds. Okay, I'm going to leave it up there just no time at all, hardly just 15 microseconds. It's just going to go up and it's going to see it, and then we can go on. So I'm not going to wait very long there. And digital write, and then we're going to go trig pin. Now we're going to go low. Okay, like that. So we go low, wait, high, wait, low, and now we need to wait again. And I'm going to delay microseconds. Delay. I pay attention because I am such a poor speller. A lot of times you're looking for these things to turn orange, telling you that it recognizes it. So we're gonna delay microseconds, and I think about let's see, I think about 10 microseconds here would be enough. You can play around with these numbers. I'm not exactly sure what you're supposed to use, but these seem to work. So I've sent this trigger thing that says send out the ping, send out the ping. So I need to now measure the ping time. Okay, where do I measure that? I measure that by using the pulse in, which will measure the length of the pulse. And where am I measuring it? I'm measuring it at echo pin, which we set up earlier, and I'm looking for a high pulse. Okay, and so what this is doing is it's looking for that high pulse. I send out the ping, and then the sensor sends me a pulse that's a high pulse, and that pulse is proportional to the strength of the color. Well, inversely proportional, because the longer the pulse width that it sends me, the weaker the color. So ping time, what am I saying? That was the other one. No, this is distance. So this is telling me basically in microseconds how long it took the ping to go out and come back. Okay, I misspoke. I was on the other sensor. So ping time is going to be the time for the ping to go out, hit the target, and come back. So I measure that, and I'm looking for a high pulse. Ping time is equal to pulse in of the echo pin, and I'm looking for a high pulse. Okay, now that ping time is going to come back in microseconds. Okay, so I need to say ping time is equal to ping time divided by 1,000,000. 1, 2, 3, 4, 5, 6. Because I want to change ping time to seconds. So I'm going to convert ping time to seconds. Okay. And now ping time is in seconds. Or no, ping time is in seconds. Now I need to put it in hours. Ping time is equal to ping time divided by 3600. Convert ping time to hours. All right. Why do I want to convert ping time to hours? Because up here I put in the speed of sound in miles per hour. So I got to use the same units here. I've got to put my ping time in hours for this to work. So now I have my ping time in hours. Okay. So now target distance is equal to the speed of sound times ping time. And I have all types of problems up there I need to fix. Okay, so I need to put my semicolon there. And I always, when I put a number in, I force it to be floating point math by putting the decimal. It's just, believe me, it's a good practice if you do that. Okay. Target distance is equal to speed of sound times ping time. So this is the distance traveled by ping to and from the target. Okay. So distance is equal to rate times time. What's the rate? It's the speed of sound. What's the time? It's the ping time. But understand that ping went from here to here and back. So that's the distance traveled by the ping. The actual distance to the target is half of that. So target distance equals target distance divided by 2, because the ping goes to and from, so we need to divide that by 2 to have it work. And again, forcing that to be floating point math. Just a good thing to do. Okay. Now, that target distance now is in what? That target distance is in miles, because speed of sound was miles per hour. So now we got to say target distance is equal to target distance, and then I need to know how many. 1 mile in inches. 1 mile in inches is 1 mile is 63,360 inches. So I need to divide by or multiply by 63,360. So 1 mile is 63,360 inches, and so I need to take the target distance in miles and multiply it by 63,360 to convert target distance to inches. Okay, so now when we print out target distance, it'll be printing out in inches, which is a nice thing to work with when you're on the scale here. So I think that that all makes sense. All right, I think we have done everything. There is no telling. I'm afraid to even hit this. Ow! What did that do? Oh, trig pin. That should be capital P. Hopefully you guys caught that when you went through. This is actually why I like declaring my variables, because then when I make a mistake, it kind of points it out, so it finds my mistakes pretty easily. And this was ping time. Man, you guys just let me get really sloppy here and nobody said anything. Ping time. Okay. Target is, man, I just got very sloppy here at the end, didn't I? Okay, it's going to like it. So far everything is good. Ooh, I think it's everything is compiling. I think it just had a little glitch on the download, but it's going to compile okay. And I know what the problem is. I've got my serial port tied up over here with this Arduino program. I mean this Python program. So this Python is locked onto the serial port, and so it's not letting my computer talk to the Arduino. So killing that should let this download now. Let's just see now. Yeah, you see I'm not getting any orange down here. All right, so that's going to work. So I made all my measurements. Now I got to print this stuff out, and what I want to do is I want to create a line of text, and that line of text is going to be R color, comma, G color, comma, B color, comma, distance. So I'm going to have one line with 4 numbers. And I can't put any formatting because, right, I'm throwing this to Python, and then Python's going to catch it. So I don't want any formatting. I just want numbers separated by commas, and then I got to keep track of it. So when I read it over there on the Python side, I remember what order those numbers are. So we're going to do a serial.print, and then I'm going to print. And then I'm going to come up here. I am such a poor speller. If I can ever spell something correctly, I'm going to copy and paste it. Okay, so I'm going to come down here, and we're going to print this because we want it on the same line, like that. And now I'm going to copy, and then what I need to do is I need to serial.print, and I need to print my comma, comma, and I put a space just so it's a little easier to read, and I can still parse that okay. And now what I'm going to do is I'm going to copy this, copy, and I'm going to paste, I'm going to paste. And so I'm going to print, and I don't want that last one. I guess I do. Okay, so I'm going to serial print R color strength, print a comma. Serial print green color strength, print a comma. Serial print blue color strength, print a comma. And then I'm going to finish up with a serial.println. And what else do I need to print? I need to print this target distance. Like that. Okay. So I'm printing RGB in the target distance. Red, green, blue in the target distance. Let's download this. Okay. It's a little scary. All right, let's look at our serial monitor. Now remember, I can't run the serial monitor while I'm running Python, but I just got to see, are these kind of reasonable numbers that I'm getting at this point? Okay. So if you look at this, with this up here, it's saying that red is the strongest, and on pink, red would be the strongest, but there is a little bit of blue in it, and that is true that this is a little bit, pink is a little red. It's red with a little bit of blue. And so that looks good. And then on my target distance, it's saying 4 inches. I come down to like 1 inch. I go out to 5 or 6 inches. And so you see this distance measurement is looking good here. You see that distance measurement is looking good, and then the color measurement is looking good. Let me just put a green up here and see what happens. If I put a green up here, look at that. Red, green is the second number. That's the biggest one. All right, let's put the purple up here. Purple is a lot of red and blue, and that is looking good. Let's put something that's mainly blue, and let's see. There is this is not reading this one real good. Doesn't like that blue very much. Let me see if I can get another blue. We might have to come back and look at that later, but let's see if I can get a better blue here and see. Red, green. So I am not reading blue. Okay, I am not reading blue here. So let's go back up here and see if we made a mistake on our blue, in our blue code. Okay, so if blue is the strongest, blue is greater than red, and red is greater than green, and blue color strength is equal to 255, R is that, and green goes to 0. And if blue is greater than, ooh, look at this, look at this. This is where the mistake was. I was setting blue equal to 0, and what this is red is the weak one. So that little corner of the parameter space didn't work. And that's a hard problem to find. I hate those kinds of problems. But let's go back and look now. Okay, we downloaded it, I think. So let's come in and look. And now, yeah, red, green, blue. So the third number here, red, green, blue. Blue is showing up the biggest. Okay, and let's go back to that other blue that we were having trouble with. Yeah, that blue is working. Let's go back to kind of our aqua. This should be some blue and some green. Yeah. All right. We have got this working now. It likes to have a target. It doesn't like to not have anything there. So this is good. Look at this. We're measuring the red, the green, and the blue in a fairly crazy but seems to work sort of way, and we're getting the distance. So we have got this program working. Tomorrow in lesson, what will tomorrow's lesson be? We are on lesson what today? We are on lesson 4. Tomorrow, lesson 5, we're going to build our virtual world in VPython, where we're going to take in Python with the VPython library. We're going to take this data stream and we're going to make a virtual world. Tune in tomorrow for Arduino or Python and Arduino, or Arduino with Python, lesson 5. See you guys tomorrow.